My dear student, welcome to School of Fundamental Sciences, SOFS. I deliver some fundamental concepts of physics, chemistry and mathematics for JEE Main and JEE Advanced from this platform. Now let us start with today's topic. Let us start calculus for physics. It's a very useful concept, to understand physics as well as chemistry also. That I'll discuss in the form of review of concept and sample problem. First you see review of concept is called RC01, idea of position vector and displacement vector. Suppose a particle is moving along the x-axis. You see figure P011. Initially P is the position of the initial position of the particle is at P, and Q is the final position of the particle. But this position can be explained by position vector concept. When the particle is at P, OP is the position vector and direction is from O to P. When the particle is at Q, OQ is the position vector for the position of the particle and its direction will be O to Q. And then what is the displacement of the particle? From P to Q, see figure P011. So PQ is equal to OQ minus OP. It is a vector equation, and the equation is valid for computation for one dimensional motion. It is a case of one dimension. That's why this vector equation PQ is equal to OQ minus OP will give you the what? The displacement vector for the particle when it moves from P to Q. That can be represented by delta x concept also. This PQ is equals to delta x equals to final minus initial. Delta x is a defined quantity. Always delta x will give the change in position vector, that means displacement vector, always equal to x final minus x initial. Now we see the message. Delta x, again I am telling you, delta x is a very very important parameter. Always for any quantity like x, like displacement, like velocity or any other quantity, always delta x represents the what? Change in the parameter. And what is it is defined as what? Delta x equals to x final minus x initial. So what is x final? X initial plus delta x. Generally we will write xi equals to x. Xi means initial is equal to x. So final is equal to what? X plus delta x. So we can write initial, any change of a variable is denoted by delta. Suppose the change of the variable x is denoted by delta x. What is the definition? How it can be defined? Delta x equals to x final minus x initial. Always. So what is x final? Xi plus delta x. Now generally xi is replaced by x. So clearly x final will be equals to what? X plus delta x. Be careful. Delta x is associated with sign. Delta x will give you positive sign. When, let us see in the sample example also, sample problem also, when we will move along the direction of increasing x, delta x becomes positive. I will again explain in sample problem. And when it is moving in the decreasing x, delta x becomes negative. Now to understand the review number RC01, let us see very carefully SP01, sample problem 01. Now sample problem 01, it is related to RC01. To understand RC01, please you see SP01 very carefully, the question as well as its solution. Suppose the motion of the particle along the x-axis is given by the law x equals to 5 meter per second square t square minus 40 meter. X is an unknown quantity. It will come out with its magnitude as well as dimension. But 40 is a what? Given quantity. So its dimension will be meter, because left hand side is what? Meter. So for the homogeneity of dimension, each and every term must be in meter. So clearly 5 must have the dimension meter per second square, because it is a t square. T square means second square. So second square, second to the power minus 2 means what? Meter. So x will be in meter. This first term will be also in meter total, and this will be in meter. That's why 5 has the dimension meter per second square. Now we have to compute the displacement of the particle in the time interval between 2 seconds and 10 seconds. So you see solution. At time ti Ti means initial time, I means initial. At initial time is equal to 2 seconds. The position vector of the PB is the position vector of the particle is, put T is equal to 2 seconds in the law, 5 meter per second square into 2 second whole square minus 40 meter equals to, you calculate. Now you see the second to the power minus 2 and second square cancel out, so it will be 20 meter minus 40 meter equals to minus 20 meter. You see in the graph also, in the diagram also, figure P01x, O is the origin, all position vector must be measured from the origin O. So xi equals to minus 20 meter. So it will be in the left side of the x-axis, because right side positive value plus 1, plus 2, plus 3 like that, and then left side number line minus 1, minus 2, minus 3, etc. So when x equals to minus 20 meter, so this is the location of xi, and what is the direction from the origin O to the point in question, that is, it is the direction of initial position vector xi at t is equal to 2 seconds. Now at t final equals to 10 seconds, the position vector of the particle, put t is equal to 10 seconds in the law, so x final equals to 5 meter per second square, 10 second square minus 40 meter, calculate, it will be plus 460 meter. So it will be on the right side, from the origin it is a plus 460 meter. Now the plus sign, now displacement of the particle, delta x. So what is delta x is a defined quantity. What is delta x? X final minus x initial always. So what it is a vector equation, be careful. So this x final as well as x initial will be replaced by magnitude as well as direction. If we move along the increasing direction, it is called positive direction. If we move along the decreasing x, it is called negative direction. Why? Now please you see, if we have a delta x will give us delta t always positive, because time always goes on increasing. Delta t is equal to t final minus t initial. T final is always greater than t initial, that's why delta t always positive, but delta x not. In this case, when the particle is moving along the positive x-axis in the rightward direction, so the final is what? More. Final position vector will be more, and the initial and the initial will be the what? Less. It is final is what? Plus 460 meter. Initially is what? Minus 20 meter. And you verify. What is delta x? Plus 460 meter minus of minus 20 meter. Xi is the what? Vector quantity. Magnitude is 20 meter. Direction is negative direction, so minus is said here. So total it will be plus 480 meter. That means delta x is a positive sign. Yes, so clearly this direction must be positive direction. Delta x is what? From initial position to final position, and it gives plus sign, and that's why this direction is called positive direction. So delta x will control the direction of sign. So when it moves along the positive x-axis in the rightward direction, delta x will give the positive sign, and that's why this direction is positive. Increasing x is always called positive direction. Similarly, if we move towards left along the decreasing x, delta x will be accordingly negative. You see next problem. So the plus sign already given tells us that the displacement of the particle, yes, will be along the positive direction. So it is a displacement. So answer is plus 480 meter. Magnitude is 480 meter, and plus sign indicating that it will be from left to right. Now RC02, concept of average velocity. So average velocity is the what? Average velocity displacement of the particle per unit time interval. That is, delta x is the displacement and delta t is the what? Time interval for this displacement. So what is the average velocity? Delta x by delta t, or delta x you can say x final minus x initial, and delta t t final minus t initial. Let us have a sample example, SP02. Motion of the particle is given by the law. We have to find the average velocity of the particle between 2 seconds and 5 seconds. So for solution. T means solution. The position vector of the particle at initial time ti is equal to 2 seconds is xi vector, initial position vector equals to, put the value of t is equal to 2 seconds here, it will be this one is equal to plus 4 meter. Now when t is equal to 5 seconds, that is t final is equal to 5 seconds, what is the Poisson vector? X final is equal to, put t is equal to 5 seconds, it will be minus 80 meter. So you see please, it is the origin, initial is plus 4 meter, so in the right side, number line, x is the number line, so plus 4 meter on the right side, and final Poisson vector is minus 80 meter, so it will be on the left side of the origin. So what is the displacement? From you see the head of the initial Poisson, displacement is always from the head of the initial Poisson vector to the head of the final Poisson vector. It is the head of the initial Poisson vector, and this is the head of the final Poisson vector. So displacement will be always from the head of the initial Poisson vector to head of the final Poisson vector, and you see delta x will give negative sign, and that's why this direction is called negative direction. So clearly in calculus, yes, when the particle is moving along the decreasing x, the direction will be always negative, and increasing x, direction will be always positive. It will be controlled by delta x as well as delta t also, but delta t always positive, so no problem. Delta x will control the sign. So what is displacement? X final minus x initial. Again I am telling you, it will be replaced by magnitude and direction. What is the magnitude? 80 meter. What is direction? Minus. Already obtained. Minus. What is the initial? Magnitude 4 meter. Direction positive, so plus. So this minus sign giving direction, this plus sign giving direction. Magnitude only 80 meter, magnitude only 4 meter. So ultimately minus 84 meter. So magnitude is what? Displacement magnitude 84 meter, minus sign giving the what? Negative direction. Then we will find the what? Average velocity. What is the time interval? Delta t. Yes, in final time 5 seconds, initial time 2 seconds, so 5 seconds minus 2 seconds to 3 seconds. What is the average velocity? Delta x by delta t, that is minus 84 meter by 3 seconds, so minus 28 meter per second. So average velocity minus 28 meter per second means magnitude 28 meter per second, negative means along the negative direction. Now RC03. Graph is very, very important in science. So we have the clear idea of, yes, graph when we plot x versus t or velocity versus t, any. In this case we will have the graphical concept of average velocity. So we will plot x versus t, x along the vertical axis and t along the horizontal axis. So it is an arbitrary graph. This is a curve like that. At t is equal to ti, so this will give the corresponding, yes, position of the particle. You see the figure, original figure P031, where position of the capital P, yes, is small p in the graph, and position of the capital Q is represented by small q in the graph. So when the particle is at P, so we will have the corresponding point small p on the graph at t is equal to ti. So at t is equal to ti, the particle will have the Poisson vector xi. At t is equal to tf, yes, so this will give the what? Final Poisson vector. So clearly this is the what? Delta x, x final minus x initial, and this is the what? Delta t, t final minus delta initial. Now what is the average velocity? We know already defined, delta x by delta t. So come here, delta x by delta t is what? Tan theta, and this tan theta is called the what? Slope of the chord PQ.